All right, so number 10, here is number 10 on the chapter 5 to 7 cumulative review. It says determine the sum or difference and express answers in lowest terms and identify non-permissible values. Okay, so let's do this work. Let's do this work over here on the right. Okay, so what we have is we have two rational functions being added together. When you recall this, okay, so from before, recall that if you have a 2/3, like a fraction, plus 5 over 7 or 6, let's say, okay. So if you're adding fractions, you have to have a common denominator. Sometimes you're going to have to multiply both fractions to get a common denominator. Sometimes you'll just have to multiply one. In this case, I would want to get a common denominator of 6, so I would do this to both sides. If this was a different number, like 7, okay, if this was 7, I would have to multiply both fractions by something. And this one I'd have to multiply by 7, top and bottom, and this one by 3, top and bottom. Okay, so hopefully you remember that, because that's exactly what we're going to have to do here for number 10. I'm going to make this a bit bigger here for us so we can see it, okay? So number 10a, let's do number 10a. And the denominators that we have are a plus 2 and a minus 7. Okay, so what's that going to look like? Well, I'm going to need to get a common denominator, and that common denominator is going to be a plus 2 times a minus 7. All right, now to get there, what you're going to want to do is multiply this rational over here by a plus 2, top and bottom. And over here, you're going to want to multiply this rational by a minus 7, top and bottom. So the same thing that we did with the regular fraction addition. Okay, so what do we have on top here? Well, 10 times a minus 7 is going to be 10a minus 70. Okay, plus, now what's over here? I'm going to use big brackets here because I'm going to have multiple terms here. So this is going to be a squared, right? A squared plus 2a minus 1a, or just minus a, and then minus 2. Okay. Are we okay with that first step? Just chat in or speak up if you're okay with that first step. Or if you're not okay, I should say. Because I'll keep going. So once we get this top part here, now we want to gather all like terms. Okay, so gather all like terms. I have an a squared, I'll write first. Okay, so that's gone. Look at all these a's here. Okay, I have 2 minus 1, that is 1a, plus 10a. So 10a plus 1a is plus 11a. Okay. So I also have negative 70 plus a minus 2. So it would be, looks like negative 72. All right, so let's double check that. A squared, 10 plus 2 is 12, minus 1 is 11. Negative 70 minus 2. All right. And on the bottom here, we have a plus 2 and a minus 7. So when you get to this point, you don't want to just circle this and be done. What you want to try first, at least, is to try to factor this thing here. If we can factor this thing here, we might be able to cancel off or divide off with one of the factors in the bottom. What we do want to make note of, though, is a cannot equal what? Well, this factor can't be 0 and this factor can't be 0. So a cannot equal negative 2 and it can't equal positive 7. So just make note of that, and then we'll move on and we'll try to factor. Okay, so can we factor this by sight? Well, let's see. Can we split that trinomial up into 2 binomials? Well, let's see. What are the factors of 72? 36 and 2. No, that's not going to work. 8 and 9. Okay. 4 and 18. Okay. So we're having, I don't know, I'm having some problems finding factors of 72 that add up to 11. Are you getting any? What about, let's see, 15 and 4? No. 16 and 5. What's 16 and 5? Nope. That's not, that's like 80. Okay. So if we can't find any, what we could do is, I mean, if we don't have a 2 or a 7 in there, so what about 18 and 7? What's 18 times 7? Does that work? No, that's too big. What about 2? 13 and 2? Nope. Okay, so it doesn't look like we're going to be able to factor this. So this can't be factored. If you graph it, see if there's any x-intercepts, or use a quadratic formula. It's not going to be factorable here, especially with a plus 2 or a minus 7. So this is your final answer right here. That is your final answer because it cannot be factored any further. Okay? So just to follow up to this question here, I did graph this on Desmos, and there are intercepts, but look at 4.612. We're not gonna be able to simplify this at all. So you don't have to factor this because you cannot divide out any of the factors. And then negative 15.612, these are not whole number ratios, so you can't divide anything out, so that's fine for a final answer. Okay, cumulative review, chapter 5 to 7, number 10. There's 285 original seats on the main floor. So we have 285 original seats, 285. The number of rows on the main floor is 4 more than the number of seats in each row. Okay, so determine the number of rows, the number of seats in each row. Okay, so the number of rows, that is the total number of rows, like this, I guess. Okay, rows sideways. This total number is 4 more than the number of seats. So the number of seats in the row we would say would be like this, I guess, right? The number of seats. And so the number of rows on the main floor is 4 more than S. So this is 4 plus S. Okay, 4 more than S is 4 plus, not 4 times. Okay, so just want to make sure you get that straight. So it looks a little bit more like this maybe. Okay, so we don't know what S is, we don't know what 4 plus S is, but we know that those have to equal 285. So determine number of rows and seats. So rows are actually going to be 4 plus S, right? That's what this is. This is equal to rows. And then S is just equal to S, or seats. So if we can find S and make some kind of equation, it appears that, I mean, I guess we're assuming this is rectangular, right? So I think you can go 4 plus S times S equals 285. That's what it looks like to me. Let's see if this works. So 4S plus S squared minus 285 equals 0. Two things I did at once there, multiplying and then that subtraction. Or S squared plus 4S minus 285 equals 0. So we could use quadratic formula. X equals negative b plus or minus root b squared minus 4ac all over 2a to find our roots. Or you could graph, if you have graphing technology. I did that. So my two answers would be a negative 19 here or positive 15. So the number of seats can't be a negative number, so we would reject that, and it appears that our solution to this equation looks like it's going to be S equals 15. Okay, S equals 15. That means that R equals 4 plus 15, or R equals 19. And if we double check this, 19 times 15, does that equal 285? Well, we could probably check that pretty quick here. Let's see, on, clear, 19 times 15 is 285. Okay, how's that look? Does that line up with the answer there?